Apply Lagrange's formula inversely to find a root of the equation f of x equals 0 given that f of 30 equals minus 30, f of 34 equals minus 13, f of 38 equals 3, f of 42 equals 18. So here four values are given, and here we have to find a root of the form f of x equals 0. So f of x equals 0 means we already know that a value x equals a is said to be a root if it satisfies a function f of x. So here f of x equals 0 means we have to find for what value of x the function f of x is becoming 0. Means y value is already given, y value is 0, we have to find the value of x. Means we have to apply Lagrange's inverse interpolation formula. So we have to find x such that f of x equals y is equal to 0. So given values are x naught equals 30, x1 equals 34, x2 equals 38, x3 equals 42, and y naught is minus 30, y1 is minus 13, y2 is 3, and y2 is 3 and y3 is 18. So now we know how to write Lagrange's inverse interpolation formula. Already we have discussed in the previous video. Here y value is given, that is y equals 0, we have to find x. So Lagrange's inverse interpolation formula. So formula is x is in terms of y. So y minus y1, y minus y2, y minus y3 into x naught. So y naught is excluded, divided by y naught minus y1 into y naught minus y2 into y naught minus y3. In the second term, y1 is excluded. In the third term, y2 is excluded, and in the fourth term, y3 is excluded. So in the first video we have discussed how to write Lagrange's interpolation formula and Lagrange's inverse interpolation formula. Go through that video. And now substitute all the values in the formula. So now x equals x of 0 because y is 0. So x of 0 or x value. So now substitute all the values. So y is 0 here. So y is 0. So 13 minus 3 minus 18 minus 18 into 30. So 13 into minus 3 into minus 18 into 30 in the denominator, minus 17 into minus 33 into minus 48 plus a second term. So y is 0. So we get 30 into minus 3 into minus 18 into x1. x1 is 34 by 17 into minus 16 into minus 31. Now third term, 30 into 13 into minus 18 into x2. x2 is 38 by y2 is 3. 33 into 16 into minus 15 plus fourth term, 30 into 13 into minus 3 into x3. x3 is 42 by y3 value is 18. So 48 into 31 into 15. So now you have to simplify each term separately. Minus 0.7821 from the first term. So after simplifying the second term, we get 6.5322. Simplifying the third term, we get 33.6181. Then simplifying the fourth term, we get minus 2.2016. So x of 0. So I am now adding all the values. We get 37.2303. So thus an approximate root of f of x equals 0 is 37.2303. Fit an interpolating polynomial of the form x equals f of y for the data, and hence find x of phi and y of phi. X and corresponding y values are given when x is 2, y is 1, when x is 10, y is 3, when x is 17, y equals 4. So now take x0 equals 2, x1 equals 10, and x2 equals 17, and corresponding y values: y0 is 1, y1 is 3, y2 is 4. So now we have to find polynomial of the form x equals f of y. Means we have to apply Lagrange's inverse interpolation formula. So if y equals f of x means we have to apply Lagrange's interpolation formula. Here they have asked to find polynomial of the form x equals f of y. Means we have to apply Lagrange's inverse interpolation formula, and we have to find the polynomial x in terms of y. So already we know how to write Lagrange's inverse interpolation formula. X equals f of y equals, in the first term y0 is excluded, y minus y1 into y minus y2 into x0 by y0 minus y1 into y0 minus y2. Now in the second term y1 is excluded, so y minus y0 into y minus y2 into x1 by y1 minus y0 into y1 minus y2, plus in the third term y2 is excluded, so y minus y0 into y minus y1 by y2 minus y0 into y2 minus y1 into x2. So now after finding the interpolating polynomial of the form x equals f of y, we have to find the values of x of phi and y of phi. So now substitute all the values in the formula, retain y as it is because we have to find the polynomial. So y minus x equals y minus 3 into y minus 4 into x0. X0 is 2 by y0. Y0 is 1. So in the denominator we get minus 2 into minus 3 plus y minus 1 into y minus 4 by y1 minus y0 into y1 minus y2, that is 2 into minus 1 into x1, x1 is 10, plus y minus 1 into y minus 3 into x2 is 17 by y2 minus y0 3 into y2 minus y1 4 minus 3, that is 1. So now simplify each term separately. So x equals in the denominator minus into minus plus 2 gets cancelled, so 1 by 3 into y minus 3 into y minus 4. Now in the second term 10 by 2, that is 5, plus into minus minus, so the remaining terms are minus 5 of y minus 1 into y minus 4 plus 17 by 3 into y minus 1 into y minus 3. Now we have to simplify further. So if you take 1 by 3 as common, or 1 by 3 into y minus 3 into y minus 4, that is y square minus 7y plus 12 minus 5 of y square minus 5y plus 4 plus 17 by 3 y square minus 4y plus 3. So you have to simplify further. You can take 1 by 3 as common. So if you take 1 by 3 as common in all the terms, in all the 3 terms, for the second term you have to multiply 3, that is 5 into 3 is 15. So you will get the polynomial x equals f of y equals y square plus 1 after simplifying is the required polynomial. So now we have to find the values of x of phi and y of phi. X of phi means the value of x when y equals 5. So at y equals 5, x value is 5 square plus 1, so x is 26. Now y of 5 means when x equals 5, we have to find the value of y. So y of 5 means at x equals 5, so we have 5 equals y square plus 1, so y square equals 4, so y equals 2. So thus x of 5 equals 26 and y of 5 equals